Welcome to Web Development Through Practice. Today, we will cover all the important PHP OOPS concepts that are commonly asked in interviews. I'll break them down with practical examples so you can confidently explain them in your interview. Let's start with what OOPS is in PHP. OOPS, Object-Oriented Programming, is a programming model that focuses on objects. An object can be anything, like a car, a person, a table, a mobile phone, or anything else. The world is naturally structured around objects, and each object has its own properties and behaviors. For example, a car properties are brand, color, speed, and fuel type, and behaviors are start, accelerate, brake, and refuel. For a person, properties are name, age, height, gender, and behaviors, walk, talk, eat, sleep. If we look at an e-commerce website, there are also objects like product, user, shopping cart, order, and payment. Each object has its own properties and behaviors. Now here is what OOPS does. It creates, organizes, and manages objects to build reusable applications. It helps in designing software where objects interact with each other efficiently. Now to organize an object's properties and behaviors in one place we use a class. That's why a class acts as a blueprint for objects. Now, let's see how this works with a practical example. Let's take an example of a user object in an e-commerce website. A user object has behaviors like registering, logging in, logging out, and updating the profile. It also has properties like name, email, and password. Now, we define a user class to organize the object's properties and behaviors in one place. After that, inside the user class, we define properties. To define these properties, we use access modifiers. So first, let me explain what an access modifier is. Access modifiers control the visibility and accessibility of properties and methods within and outside a class. There are three types of access modifiers in OOPS: public, protected, and private. Now, if we define properties using the public access modifier, we can write public $name is equal to John, public $email is equal to john@example.com, public $password is equal to password123. Here, I have provided static values for testing. Now, I create a user class object and try to access these properties by echoing the message and saving the file. Then, to see the output, run the code, and you can see that I can easily access public properties from outside the class. Now, let's modify the property values. Name is equal to Nick, email is equal to nick@example.com, and password is equal to nick123. After saving the file and running the code, you can see that the modified values are displayed. This means that if we use the public access modifier, we can easily access and modify properties or methods from anywhere, and it is not secure for sensitive data like passwords, bank account details, or any other private information. Similarly, define user class behaviors such as register, login, log out, and update profile, and you can add your logic to implement these user class behaviors. I am just showing a simple message. These behaviors are also referred to as functions or methods. Now, to access these methods, we already have an object of the user class. Simply call the method by its name. For example, call the register method and save the file. Then run the code, and you see the output for the register method. Similarly, you can apply it to other methods. So here, a class is a template that holds properties and methods. An object is an instance of a class. By creating an object, we can use its properties and methods. Now, if I change the public access modifier to protected, remove the section for modifying property values, and save the file, running the code will result in an error. This is because protected properties cannot be accessed or modified outside the class. Similarly, if I change the protected access modifier to private, save the file, and run the code again, it will show an error. The private access modifier is not accessible outside the class. The difference between private and protected access modifiers is that protected properties can be used inside the class and in child classes, and private properties can only be used inside the same class. Now, since child classes are part of inheritance, let's first learn about inheritance and then see how protected and private properties work in it. Before discussing inheritance, let's first understand constructors and destructors. In our code, we initially defined properties with static values. However, when using the user class for registration, we cannot define static data for each user. So, I removed the static values and implemented a constructor to set dynamic properties. A constructor is a unique method that automatically runs when an object is created. Let's see how it works. First, I removed the existing code and added a simple example. Inside the constructor, I display a message user object created. Then, I create an object of the user class and save the file. When I run the code, the message appears automatically, without calling the constructor manually. Now let's understand why we use a constructor. The main purpose of a constructor is to set dynamic properties when an object is created. For example, during user registration, we receive dynamic values like name is equal to John, email is equal to john@example.com, and password is equal to password123. When a user submits the registration form, the form data is sent to a backend script for validation. Then, a user object is created, and the user's data is passed as arguments. Here, when we create a user class object, then the constructor is called automatically and assigns these values to user class defined properties. $this name is equal to $name, $this email is equal to $email, $this password is equal to $password. These properties are now available for all methods in the user class. For example, if we call the register method, it uses these values for registration. If we then call login, the same values can be used for login without passing them again. Benefits of using a constructor: reusable data. The same properties can be used for multiple operations such as register, login, and update profile without needing to pass arguments to each method separately. Other uses of constructors are: a constructor can automatically connect to the database. For example, suppose you have a database connection file, db.php. You can include this file at the top of your code. Then, inside the constructor, create an object of the database class and store it in the $db property. Then, call the connection method and store it in $thisCon, while also defining private $con to hold the connection. Now, you can use $con to perform database operations in various methods of the class, such as inserting user registration details, handling login, and more. In PHP 8+, we can define access modifiers, private, protected, public, and data types directly in constructor parameters. So, you don't need to declare properties separately. However, access modifiers cannot be used inside regular function parameters, making this a key advantage of constructors. Next, we can also define strict return types for functions. For example, first enable strict type by declaring strict_types is equal to 1, and we define an is logged in function that must return a boolean, but if returns an integer 10, PHP will throw a type error because 10 is not a boolean. This is called strict typing, ensuring better code reliability and improving accuracy and consistency. Similarly, you can apply return types to other methods, such as a register method that returns a string as a success message. Now, let's discuss destructors. A destructor is the opposite of a constructor. It is called automatically when a class object is destroyed or the script ends. It is mainly used to clean up resources, such as closing database connections or writing logs. In our example, we define a destructor method and use it to close the database connection. Once the script has executed all previous code, the destructor will run automatically. Save the file and you can observe how it works after all other code has finished executing. Next, let's discuss inheritance. In simple words, inheritance means taking or extending something from someone else. Imagine, you don't have a house, but your father has one. So, you don't need to buy the same things that already exist in your father's house, such as a Samsung TV, wooden table, leather sofa, and more. This means you can use everything in your father's house for your needs. We can relate this situation to object-oriented programming. Here, we have two classes, the father class which owns properties like the TV, table, and sofa. The U class has no properties but can use the items from the father class. Since you inherited things from your father, the father class is called the parent class, and the U class, that inherits from it, is called the child class. In OOPS, the parent class is also known as the base class, and the child class is known as the derived class. This is exactly how inheritance works in programming. The child class means you get access to all the properties and behaviors of the father-parent class without defining means buying them again. Similarly, if you want to add new items to your father's house, you can buy things that are not already there, like video games. However, if you buy something that already exists in your father's house, such as a Samsung TV, it replaces or overrides the one in your father's house item. Now, let's see how it works with a practical example. To implement this functionality, I create two class files, one for the father class and another for the U class. In the father class file, I define a father class with properties such as public $TV is equal to Samsung TV, public $table is equal to wooden table, and public $sofa is equal to leather sofa. Additionally, I define methods like useTable, useSofa, and watchTV, which return simple messages. After defining the class, I save the father class file. In the U class file, since the U class does not define its own properties, it extends the father class to inherit its properties and methods. To do this, I first include the father class file in the U class file. Next, I use the extends keyword to inherit from the father class. To perform an action, I create an object of the U class, and then I call the watchTV method, which belongs to the father class. After saving the U class file and in the output, the message from watchTV is displayed. This confirms that the U class, child class, successfully accessed the properties and methods of the parent class, father. Next, the U class decides to add a new item, like a video game, extending the items from the parent. In the U class, I define a property called public $new item is equal to video game and a method called playgame that returns a simple message. Now, when I call playgame and in the output, the message playing video game is displayed. This shows that the child class can add its own properties and methods. Next, if the child class wants to define a property or method that already exists in the parent class, such as TV and the watchTV method, it can do so by redefining them. Public $TV is equal to my own Samsung TV. Similarly, the child class can redefine the watchTV method. Now, when I call watchTV, it overrides the parent class method, displaying the new message, I am watching my own TV. It is also worth noting that if we create an object of the parent class and try to call the same method, watchTV, the parent class's properties and methods remain unchanged. This concept is known as single inheritance, where one child class derives from one parent class. Now, let's discuss the noted point of how protected and private access modifiers work with inheritance. In a father class, suppose there is a Wi-Fi password property that is initially public, meaning anyone can access it. However, the father wants to share it only with family members such as with child classes and not with outsiders. So, we use the protected access modifier. This ensures that only the father class and its child classes like the U class can access it. To implement this, we define a getWiFi password method in the uChild class, which accesses the protected Wi-Fi password property. When we call this method and run the code, you can see the output. The child class can successfully retrieve the Wi-Fi password. However, if another class which not related to the father class, such as the neighbor class, defines the getWiFi password method and to access the father class Wi-Fi password property, include the father class file and create the object of the father class and return Wi-Fi password property in this method. Now to test this, create an object of the neighbor class, try to access the getWiFi password method and run the code. It shows an error because protected properties cannot be accessed outside the class hierarchy. So, protected properties can be accessed inside the class and in child classes. Now, let's say the father has a money locker password, which is strictly private and should not be shared with anyone, including family members. So, we use the private access modifier. This ensures that only the father class can access it and even child classes cannot access or modify it. Now to test this, we define the getLockerPassword method inside the uChild class and return a simple message with the locker password. Now call this getLockerPassword method and save the file. Now run the code and the output shows an error because can be accessed only inside the same class, not even child classes. Next, let's discuss when to use inheritance in programming. Inheritance is used to reuse code and establish a relationship between classes where a child class inherits public or protected properties and methods from a parent class while also having the ability to extend or modify them. Another type of inheritance is multilevel inheritance. This occurs when a class is derived from another class that is already derived from a third class. A simple example is a family hierarchy. The father class inherits from the grandfather class, and the son class inherits from the father class. Here, the father class is already derived from the grandfather class, creating a multilevel structure. As a result, the son has access to the properties and methods of both the grandfather and the father class. Similarly, in an e-commerce website, the admin class inherits from the user class, and the super admin class inherits from the admin class. In this case, the super admin indirectly inherits the public and protected methods and properties of the user class. Now, it's important to note that you should use multilevel inheritance only when there is a clear hierarchical relationship between classes. Now, let's implement this concept practically. To implement multilevel inheritance in an e-commerce website, we have three classes. One is a user class which contains common functionalities like register, login, logout, update profile, and get details. The second is an admin class, which extends the user class and also has own functionalities for managing users and products. Now, when we create an object of the admin class and call the getDetails method from the user class, it returns the admin's name and email. Here you can notice that we reuse the getDetails method, as there is no need to define a separate method to fetch admin data within the admin class. Same as for admin register, login, and logout, we can use the same user class methods. Now, the next class is the super admin class. This class extends the admin class. When we create an object of the super admin class and call the getDetails method of the user class, it returns the name and email of the super admin. Additionally, if we call a method from the admin class, such as retrieving the user list, the super admin has access to all relevant data. Thus, the super admin class is derived from admin, which is already derived from user, forming a multilevel inheritance structure where each class builds upon the previous one, ensuring code reusability and hierarchy-based access control. The next type of inheritance is multiple inheritance. Here, multiple means that we can extend more than one class. For example, consider a user class that defines common functionalities such as registering, logging in, logging out, updating a profile, and retrieving details. There is also an admin class that extends the user class and adds its own properties and methods for managing user data and product data. Furthermore, we have a superadmin class that extends the admin class and includes its own properties and methods for managing admin data. Now, let's introduce another class called seller, which also extends the user class and has its own properties and methods, such as managing sales reports. Now, the superadmin class, which manages admin data, may also want to manage data from the seller class. This is where multiple inheritance comes into play, allowing the superadmin class to extend both the admin and seller classes, using a comma to separate the class names. However, if we try to run this code in PHP, it will result in an error because PHP does not support multiple inheritance. The primary reasons are method conflicts, ambiguity, and the diamond problem. For example, the admin class can access the getDetails method from the user class to retrieve admin details by passing the admin ID. Similarly, the seller class can call the getDetails method from the user class by passing the seller ID. If the superadmin class attempts to call the getDetails method from the user class, it will encounter two identical copies of the method, one from the admin class and one from the seller class. This creates the diamond problem. Additionally, if the admin class has a method called manageOrder for approving or rejecting orders, and the seller class has its own manageOrder method for processing customer orders, a conflict arises. When the superadmin class tries to access the manageOrder method, ambiguity occurs because it is unclear which method should be executed, the one from the admin class or the one from the seller class. To resolve these issues, use traits or composition instead of using multiple inheritance. A trait is a way to define methods that can be reused across multiple classes. In our example, the superadmin class wants to access the functionalities of both the admin and seller classes to manage the system. Since we cannot use multiple inheritance, we create separate trait files, one for admin called admin_trait and another for seller called seller_trait, and remove the extensions to admin and seller classes from superadmin. In the admin_trait file, we define the trait using the trait keyword and name it admin_trait. In the seller_trait file, we do the same and name it seller_trait. Now, if we convert all the functionalities of the admin and seller classes into traits, we won't be able to access the user class functionalities because both the admin and seller classes extend the user class. Therefore, we cannot convert the entire class into traits. We do not make any changes to the admin and seller class files. Instead, we extract only the reusable code from the admin and seller classes, such as the manageOrder method. To do this in admin_trait, we define the manageOrder method from the admin class and remove the existing manageOrder method from the admin class. Similarly, in seller_trait, we define the manageOrder method from the seller class and remove it from the seller class as well. You may wonder why we create separate trait files for admin and seller. We could create one common trait file, such as order_trait, and define the manageOrder method there, passing a role type to fetch order records. However, if we need to change the logic or update functionalities for admin in the future, it might affect the seller's manageOrder method, leading to tight coupling, and if the admin needs to use that common trait file, it will also include the seller's code, which is not ideal. This is why we create separate traits for admin and seller, where we define common functionalities that can be used in multiple classes. After defining the traits, we include the admin_trait and seller_trait files in the superadmin class, and we then use admin_trait and seller_trait with the use keyword. Next, we define a new method called getAdminOrders, which calls the manageOrder method from admin_trait. Similarly, we define a method called getSellerOrders, which calls the ManageOrder method from SellerTrade. At this point, we face a challenge. How does SuperAdmin know which ManageOrder method belongs to AdminTrade and which belongs to SellerTrade? To resolve this issue, we can use the instead of and as operators. Before implementing this, note that the SuperAdmin class does not extend the user class. As a result, we cannot access the name properties of the user class in the ManageAdmins method, which will lead to an error. Therefore, please remove the ManageAdmins method from the SuperAdmin class and also remove arguments from the SuperAdmin class object. Next, in the use keyword, define admin trait with the scope resolution operator for the ManageOrders method instead of SellerTrade. So, when you call the ManageOrders method, it comes from the admin trait. Then, define the SellerTrade and use the scope resolution operator to rename its ManageOrders method as ManageOrder as seller. This way, when you call ManageOrder as seller, it comes from the seller trait. Now, in the getAdminOrders method, there is no need to change the ManageOrders method because we use the instead of keyword. This means that if both admin trait and seller trait have a ManageOrders method, it always comes from admin trait. At the same time, we rename the ManageOrders method from seller trait as ManageOrder as seller, so in the getSellerOrders method, we call ManageOrder as seller. Next, in the SuperAdmin object, when you call the getAdminOrders method, it returns results from admin trait. If you call the getSellerOrders method, it returns results from seller trait. However, the issue is not yet resolved because the SuperAdmin class should have all functionalities of both admin and seller classes, not just the common functionalities. For example, if SuperAdmin needs to manage admin users and access seller sales reports, we cannot use traits. Instead, we use composition, which follows has a relationship between classes. For example, the SuperAdmin class has admin and seller class functionalities. We achieve this by creating objects of admin and seller classes inside the SuperAdmin class. Before implementing composition, we remove the trait code of admin trait and seller trait, otherwise, it will show an error. To implement composition by creating objects of the admin and seller classes within the SuperAdmin class, we start by including the files for the admin and seller classes in the SuperAdmin class. Next, we define properties such as private $admin to store the admin class object and private $seller to store the seller class object. We then create a constructor where we instantiate an object of the admin class and assign it to the $admin property. Now, if we check the admin class, we see that it extends the user class, and the user class has a constructor that requires a name, email, and password. However, in the SuperAdmin class, when creating an admin object, SuperAdmin does not have the admin password. To resolve this, in the SuperAdmin class object, we pass the admin name as admin user, the email as admin@example.com, and the password as null. In the SuperAdmin class constructor, we receive these details as parameters, such as $admin name, $admin email, and $admin password is equal to null. Then, we pass $admin name, $admin email, and $admin password into the admin class object. Similarly, if we check the seller class, it also extends the user class, which requires a name, email, and password in its constructor. When creating an object of the seller class, SuperAdmin does not have the seller's password. To resolve this, in the SuperAdmin class object, we pass the seller's name as seller user, the email as seller@example.com, and the password as null. The constructor receives these parameters as $seller name, $seller email, and $seller password is equal to null, then passes them into the seller class object, assigning it to the $seller property. This approach allows us to access functionalities from both the admin and seller classes. For example, we define a method called getAdminOrders, which returns the result of the ManageOrders method from the admin class object. Similarly, we define a method called getSellerOrders, which returns the result of the manage_orders method from the seller class object. When we call the getAdminOrders method, the superadmin class successfully accesses the admin functionalities. Likewise, when we call the getSellerOrders method, we receive the result from the seller class. While this approach allows access to various functionalities of the admin and seller classes, it has a drawback. We cannot perform unit testing on the superadmin class because it directly depends on the admin and seller classes. This creates tight coupling, meaning that superadmin depends heavily on admin and seller, making future modifications challenging. To resolve this issue, we use dependency injection. Dependency injection means injecting dependencies rather than creating them inside a class. For example, instead of the superadmin class creating its dependencies, such as admin and seller class objects, they are passed to the superadmin class from the outside. Let's see how to achieve this. First, move the admin class object creation outside the superadmin class and store it in the $admin variable. Similarly, move the seller class object creation outside the superadmin class and store it in the $seller variable. Next, when creating the superadmin class object, remove the parameters and instead pass the $admin and $seller variables. Now, in the superadmin class constructor, modify the parameters to accept admin $admin and seller $seller. Here, the admin $admin and seller $seller parameters use type hinting, meaning that PHP ensures that the arguments passed to the constructor must be objects of the admin and seller classes. Next, assign $admin to the superadmin class's $admin property so it can be used within the class. Similarly, assign $seller to the superadmin class's $seller property for use within the class. Since the getAdminOrders and getSellerOrders methods already use these properties, no further changes are needed. Now, when calling the getAdminOrders method and running the code, you see that the superadmin class successfully accesses admin class functionalities. Similarly, when calling the getSellerOrders method and running the code, the superadmin class successfully accesses seller class functionalities. This approach reduces tight coupling between classes and makes unit testing, scalability, and maintainability easier. So far, we have covered classes, objects, properties, methods, access modifiers, constructors, destructors, single inheritance, multiple inheritance, traits, composition, dependency injection, and method overriding. Now, let's discuss interfaces. We continue with the same example, where we have a user class, an admin class, a seller class, and a superadmin class. The admin and seller classes extend the user class, and the superadmin class needs to access functionalities of both admin and seller. We have already achieved this using composition and dependency injection. We also tried using admin trait and seller trait, but since traits are used for common functionalities, they do not solve the multiple inheritance issue. Now, let's try interfaces. The goal is to solve the multiple inheritance issue, meaning superadmin should be able to access admin and seller functionalities. First, we create an admin interface file for the admin class and define the interface using the interface keyword. Similarly, we create a seller interface file for the seller class and define the seller interface. Now, if we convert the admin class into admin interface, the admin class cannot inherit from the user class. The same applies to the seller class. So, converting an entire class into an interface is not a good idea. So, let's see if interfaces can be used for code reusability. Suppose both admin and seller classes have a manage_orders method but with own logic. We move the manage_orders method of the admin class into admin interface and the manage_orders method of the seller class into seller interface. However, in interfaces, methods cannot have logic, which means interface methods must be empty, which is only defined, not implemented, and these methods are known as abstract methods. Next, If we include admin interface and seller interface in the superadmin class, we cannot use them directly. Interfaces must be implemented by a class. So, if superadmin implements admin interface, it must define the manage orders method with its own logic. However, if superadmin also implements seller interface, there will be a method name conflict because both interfaces contain manage orders. So, if interfaces do not solve multiple inheritance issues and do not provide code reusability like traits, why use them? The answer is that interfaces help create a contract in a project. For example, if we create a manage orders interface as a contract for admin, seller, and superadmin classes, then we must implement this interface and define the manage orders method in these classes. If any class forgets to define this method, PHP will show an error. So, note the point that interfaces do not allow properties, and all methods must be public and abstract methods. Interfaces are useful when you need to ensure specific methods exist in different classes with different implementations. Next, interfaces enable polymorphism, abstraction, encapsulation, and inheritance. These concepts will be explained in the next video. Don't forget to like, share, and subscribe for more content.